to calculate the area of each figure, and it says figures are not drawn to scale. All that means is that if we cut this section into 6 equal parts, this is not going to be 15 pieces that are the same size. So to find the area of triangles, we use 1/2 base times height. In this one, the diagonal pieces, or the slanted sides, are just there to distract us, so we can cross those out on all of these. We want to use the base and height that are perpendicular to each other, meaning they cross at a right angle. The base of this triangle is the whole way across. And 15 combined with 6 is going to make 21. So we want 1/2 times 21 times a height, which is 8. So we can use 1/2 of 8, and 1/2 of 8 is 4. So A equals 21 times 4. And if we multiply 21 by 4, we get 84. It was measured in inches, and area is 2-dimensional. Over here on number 2, the base is 72, and the height is 21. 1/2 of 72 is 36. So to find out what that area is, we would do 1 times 6 and 1 times 3. Then we would use our place value spacer. 2 times 6 is 12. Carry our 1. 2 times 3 is 6, plus 1 more makes 7. So the area of number 2 is 756 meters squared. This one is trying to trick you because this little dashed part right here is not actually part of the base. The only piece that makes up the base is this chunk that's actually making up a side length of the triangle. This is a distractor. All right, so we need 1/2 of 75.8 times 29.2. 1/2 of 29 would be 14.5, and 1/2 of 0.2 would be 0.1. So 14.5 and 0.1 would make 14.6. So on the side, we can multiply those out. Oh, 14.6. 6 times 8 is 48. 6 times 5 is 30, plus 4 more makes 34. 6 times 7 is 42. Plus 3 more is 45. Then use a place value spacer. 4 times 8 is 32. 4 times 5 is 20, plus 3 more makes 23. 4 times 7 is 28, plus 2 more makes 30. Now we need 2 place value spacers. 1 times 8 is 8, 1 times 5 is 5, and 1 times 7 is 7. We had 1, 2 decimal places in our question, so 1, 2 decimal places in our answer, which means the area is 1,106.68 kilometers squared.